Hi there, hope you have a fantastic day today. This lesson I will teach you annuities. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, at the beginning of each year, Tara invests $1,200. How much money will she have at the end of 6 years if interest is paid at 5% per annum, which means 5% per year? So very important is we know that at the beginning of the year, okay, each year. And then we want to work out how much she have at the end of 6 years, okay, at the end. This means that at the beginning, Tara put $1,200 in. At the end of the year, she will have interest on top of that as well. So what we do, we just need to work out how much she have at the end of each year, and then we add them up. So therefore, first of all, we'll find out the first deposit. That means at the end of year one. So we use compound interest. Remember, A is P 1 plus R power of N. So in this case, N is 1 because we work out 1 year at a time. So at the end of first year, so at the beginning, she put $1,200 in. So by the end of the year, she will get 5% on top of that. So we use compound interest. So times by 1 plus R is 5%, 5 over 100, power 1. But then we know that 1 plus 5 over 100, or 1 plus 5%, so that is 1.05. So power 1, so it's still the same as 1.05. So let me just rewrite this. So this is I1 is equal to 1,200 and times by 1.05. This is exactly the same. So that is how much you have at the end of first year. So at the end of second year, so let me just write this down. At the end of second year, of course, you have some money in the bank already on the first year. So the first year is A1 and she get interest on top of that as well. So the whatever balance in her account and she get interest of 1.05. So that means she will have this much at the end of the second year. But then also at the beginning of second year, she also deposit $1,200. And by the end of the second year, this $1,200 also have interest. So that will be times by 1.05. So that will be how much you have at the end of second years. So we know that I1, 1,200 times 1.05. So let me just rewrite this first. So that is equal to 1,200 we times 1.05. That is A1, and then we times 1.05 as well. And we add 1,200 times 1.05. That is how much she has at the end of second year. So let me just rewrite this because 1.05 we times 1.05 is equal to 1.05 square. So let me rewrite this. This is exactly the same as 1,200 we times 1.05 square. And don't forget we add that one, which is 1,200 times 1.05. So this is how much she has at the end of second year. Now, at the end of third year, so this means that the second year we have interest on top. So this means that I2 times 1.05 and she deposit $1,200 at the beginning of third year and we times by 1.05. So that is at the end of third year. But then we know that I2 is this one here. So what I do, I just put that in, replace with I2 with the series. So I2 is equal 1,200 we times 1.05 square. We add 1,200 times 1.05 and we times 1.05. So of course we need to bracket this times by 1.05. And this 105 is this one here. Okay, keep that in mind. and then we need to add 1,200 times 1.05. So that's it. That is then a third year. So let me just expand this out. So this will give me, so if I expand this time together, so this give me 1,200 times 1.05 times 1.05 square. So that will give me 1.05 power 3. And we add, and this time together, so 1.05, we times another 1.05. So the answer is 1.05 square. So that is 1,200 times 1.05 square. And we add 1,200 times 1.05. So we just leave like that. So what I do now is I can take out the common factor. So just make it easier, simpler, that's all. So I can either take out 1,200 or I can take out 1,200 times 1.05, okay? So let's just take the common factor out. That is 1,200 times 1.05, okay? That is the common factor. So let me take it out. So 1,200 and we times 1.05. That's a common factor. So in another word, the 1,200, I take it out already for this term. And then this 1.05 power 3, I take one of them out. So that will be equal to 1.05 power 2. So 1.05 square. And then we add, of course, this 1,200, I just removed it already by taking it out. And then this is power 2. So I took one of them out. So leave with 1.05. 1.05. And we add, of course, 1,200 times 1.05. I took it outside the bracket. So we leave with 1. So there you go. So let me just write the series in increasing order. Easier to see. Okay. So I rewrite this. So 1,200 times 1.05 with brackets, rewrite in order. So 1 plus 1.05 plus 1.05 square. Now that is at the end of third year. And you can see there is a pattern. So if it is 3, so that means 1 plus 1.05, 1 and plus 1.05 square. So it's 1 less, okay? And we want to work out at the end of 6 years. So which is A6. So therefore, that become 1,200 times 1.05 and then 1 plus 1.05 plus 1.05 square and plus all the way to 1.05 power 5, 1 less. Okay, so keep that in mind. So which is 1 plus 1.05, we add 1.05 square, we add, and then we add 1.05 power 5. Now don't forget, because it's 6, so it should give me 5. And don't forget, inside this series here is also 6 terms, because 1 is exactly the same as, this is exactly the same as 1.05 power 0, if you like. So from 0 all the way to 5, so 6 terms. And now what I'm going to do is I'm just going to add the series together. Okay, so this one here and this series here, we just add. The rule for this is S of n equal A bracket R power n minus 1 over R minus 1, because R is greater than 1. So we use R power n minus 1. Don't forget, okay? So A is 1. So let me just substitute this value in. And we know that A is this term here is 1. So it's 1 bracket. So R is 1.05 because 1.05 divided by 1 is 1.05. So I just use term 2 over term 1. Okay. So R is 1.05 power n. N is 6 because 6 terms all together. And we minus 1 brackets over 1.05, we minus 1. So there you go. I just put that on a calculator. So I just go fractions 1, I can ignore that. So now 1.05 power of 6, and then we minus 1, and then 1.05 minus 1. So there you go, 6.0819 and so on. Let me just write down to 2 decimal places we do, because I'm going to use this number later on anyway, so I can use the number from the calculator. So I just write, so that is equal to 6.80 we do. So now therefore A6 is equal to, okay, this number here we times by 6.80. So 1,200 times 1.05 times 6.80. So that will give me, so I just put that on a calculator. So I just go 1200 times 1.05 times the answer. So there you go, $8,570.41. And remember, with money, we write correct to 2 decimal places. So 8570.41. So there you go. So therefore, Tara will have $8,570.41 at the end of 6 years. There you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, we know that the most important word in here is at the beginning of each year, okay? And then we need to work out at the end of 5 years. So this means that Ethan deposit $2,500 at the beginning of the year. So at the end of the year, that $2,500 will have interest on top of that. So therefore, we write A1 is equal to, remember, A is equal to P 1 plus R power of N. So don't forget, P is $2,500. And R is 8%. So 1 plus 8 over 100. N is 1, of course. But of course, we're not going to write that. So we write in shortcut. So that becomes 2,500. And if you put down a calculator, 1 plus 8 over 100, you should get 1.08. Okay, so just to let you know. So that is at the end of first year. And at the end of second year, A2, so this means that A1 has interest on top of that. So A1 times 1.08. And he also add 2,500 on top of that, because at the beginning of second year, and by the end of the second year, and it has interest on top of that as well. So that means 1.08. So that is how much Nathan has at the end of second year. And we know that A1, this A1 here is this. So let me just rewrite it out. So that will give me A1 is 2,500, and we times 1.08, that is A1. And we times 1.08 as well, so that becomes 1.08 squared. And then don't forget, we add this number down, so that is 2,500 times 1.08. And let's just work out at the end of third year. I always do at least, okay, up to third year, so you can see the pattern, okay? That's quite important. So let me just write one more time. So A3 is equal to, so we have A2 times 1.08. So that is the interest. And then at the beginning of A3, which is at the beginning of third year, Ethan also put 2,500. And with this 2,500, and also have interest. So times by 1.08. That's the balance at the end of third year. But then we know that A2 is this amount here. So now I just need to write this down. That will give me A2 is 2,500 times 1.08 squared we add 2,500 times 1.08, and then we times by 1.08. So times 1.08, and then we add 2,000. Don't forget this is the amount. 500 times 1.08. So now let me just remove the bracket first. So this times this will give me power of 3. So that will give me 2,500 times 1.08 power of 3. We add and this time together. So that will give me 2,500 times 1.08 square. And we add 2,500 times 1.08. So there you go. So let me just take out the common factor first, so it makes it easier, okay? That's all. So the common factor in this case here, I can take out 2,500, okay? And times 1.08. So I take 2,500 times 1.08 brackets, and then that term, we take it out, and this cube, so take one of them out, becomes square. So 1.08 square, we add, so this we take it out, and 2, we take one of them. So now left with 1.08, and we add, and the common factor of this, we took the whole lot out, so remaining 1. So there you go. So let me just rewrite in order, so make it easier for us, okay? So now that is equal to 2,500 times 1.08. We add 1 plus 1.08. We plus 1.08 square. So there you go. So that is at the end of third year. And we can see the pattern here. If A3, so this is power of 2, and we need to work out A5, okay, at the end of fifth year. So it should be all the ways 1 plus 0.8 and 0.8 squared and so on, all the way to 1.08 power 4. So keep that in mind, always 1 less. So now that becomes, so A5 is equal to 2,500 times 1.08, 1 plus 1.08 plus 1.08 square. We add 1.08 power 4. And don't forget, this is 5 terms, okay? Power 4, because it starts from 0 all the way to 4, so 5 terms. So now what I do, I just add this series together. So S of n, the rule for this is r power of n minus 1 over r minus 1. And a is equal to 1. So 1 brackets r is 1.08, and there are 5 terms together, so power 5. And we minus 1 over 1.08 minus 1. So that will give me, so now I just put down a calculator. So I just go fractions, so I can ignore 1. So 1.08 power 5, and then minus 1, go down 1.08, we minus 1. So there you go, 5.866 and so on. So let me just write down 5.87, okay? So 5.87. So now A5, let me just move this up a bit. So now A5 is equal to 2,500 times 1.08, 2,500 times 1.08, we times the series 5.87. So that is equal to, so what I do, I just put down on a calculator. So that is 2,500 times 1.08 times the answer. So there you go, $15,839.82. So let me just write this down. 15839.92. So therefore, There you go. I hope you got it correct and thank you so much for watching. Bye.